Have a good day, students. Welcome back to another lecture video. So in this lecture we are going to see about the damped oscillation. So in the previous lecture we have seen the simple harmonic motion, how to get the differential equation for a simple harmonic motion, and also different types of oscillation. So in that different types we have seen three types. One is free oscillation, then damped oscillation, and the third one is forced oscillation. So free oscillation, there will be no restriction from the external parameters or anything. So the oscillation that is happening in the vacuum condition, it will goes on indefinite oscillation. But the damped and forced oscillation, there will be some obstructions will be there. So first let us see about the damped oscillation. We are going to obtain the differential equation for the damped oscillation, and from that let us obtain the solution for that. And in another one lecture we shall see we shall discuss about the different cases. Okay, so first damped oscillation. Okay, so in this lecture we are going to see the differential equation and its solution to the damped oscillation. Okay, so at first we take a mass m, that is suspended at one end of the spring, so other end is fixed to some support. So at first you just keep it in the air, and then the same is just keep inside the some liquid. So partially immersed inside the liquid, not fully immersed, partially immersed in the liquid. So the damping force will be more in the case of liquid than that of the damping force due to the air. Okay, so it will comes to end, that means the oscillation comes to end quickly than the air. Okay, right. So here in a kind of damped oscillation, what are the things happen? So here you can see, first a restoring force will occur. So that is directly proportional to the displacement of the body, but in the opposite direction. Okay, so it is mentioned as minus mu into y. So this mu is the restoring force constant, the proportionality constant, and y is the displacement of the body. And the second one is the frictional force. So that is proportional to the velocity of that body. So it is mentioned by minus r, so that is also in the opposite direction. Here displacement is also happen in the opposite direction. So let me explain with this diagram, that is for a simple pendulum. So here you are at first you are giving some normal force. So the force is restored here, and the displacement force is in this direction, and the displacement will be, force is from this direction, displacement is in opposite direction. So minus mu into y, and the frictional force that is due to the air, that frictional force is proportional to the velocity of the body, but in the opposite direction. So that's also in the opposite direction, so negative sign. So just denote the significance of this negative sign. Minus r, here this r is the frictional force constant, there is a proportionality constant, into dy by dt. So one of my students asked, as the friction increases, the velocity will decrease, then how come it will be directly proportional? Okay, that was a nice question, but I have referred a lot, and then I got some idea regarding that. Let me tell you that. So generally this is the normal force, so you are extending this to a particular extent, that is, then you are leaving that. So that is the normal force at first you have given. Then or in this condition, here in this spring condition, because of the mass itself, a force will be there, that is a normal force. And mu, this is the frictional coefficient or friction coefficient of that medium. So frictional force is given by mu into n. Okay, and this friction is of two types. One is static friction, another one is kinetic friction. If a ball is kept on a cement surface, so it is at rest, so that has a coefficient that is called a static friction. And for kinetic, when the ball is moving over that surface, that is on the cement surface, then it has a different form of friction that is called as kinetic friction. So here it has some value, this air has some value, that is the friction coefficient. So that will act on to the normal force. Since it is very smaller value, it will reduce that force. And what happened to the velocity at the same time? The velocity will change. But the friction coefficient is same, that is a constant for that particular medium. So when the oscillation goes on, the velocity also decreases and the frictional force also decreases. So as the frictional force decreases, velocity also decreases. So it is directly proportional. Okay, right. Now let us come up with some mathematical equation with the help of this. Okay, so we got two things. One is the restoring force and another one is the frictional force. Now you know, according to Newton's second law, the force applied, that is directly proportional to the rate of change of momentum, that is the mass into acceleration ma. So here it is given by mass into d square y by dt square, right? Now you just equate these two. So m into d square y by dt square is equal to minus mu y minus r into dy by dt. So the sum of frictional and restoring force. So you got these values. And if you take this m to the right hand side, it becomes minus mu by m and minus r by m. Then again take it to the left hand side. So you will get this equation d square y by dt square plus r by m into dy by dt plus mu by m into y. And here we have take some consideration for r by m and mu by m. So for r by m we have to use this 2b value. This is meant for this frictional force, and this is meant for the restoring force. Okay, so mu by m, it is omega square, which is similar to that of the first case. That is simple harmonic motion. So this is equation number 1. Now we got a differential equation. So when there is a differential equation, it should have a solution. So for this second degree differential equation, the value of that is the solution is y is equal to a into e power alpha t. Okay, so you got equation number 2. Then you differentiate this dy by dt. So you know, for e power ax, that is a into e power ax once if you differentiate it once. So dy by dt is equal to alpha into a into e power alpha t, and again you are differentiating again the same. So alpha, already alpha is there, so alpha square into a into e power alpha t. Now you substitute this equation 2, 3 and 4 in equation 1. So you will get the values like this: alpha square into a into e power alpha t, 2b alpha into a into e power alpha t, and omega square into a into e power alpha t. So here this is common value, this is a common value, this is also. So a into e power alpha t is common in all the cases. Take it outside. So alpha square plus 2b alpha plus omega square, that is equal to 0. So from this equation, this value 1 becomes 0. It has certain value. Okay, so there is some impact onto that value. So this is not equal to 0. So definitely the value inside the bracket, that will be equal to 0. It is in the form of a quadratic equation. quadratic equation. Now you use this formula minus b plus or minus b into square root of b square minus 4ac by 2a. So this is the general quadratic equation. From that a, b and c, if you know that values, you can easily find the roots. So a equal to 1 here, b is equal to 2b and c is equal to omega square. Okay, so substituting everything, and finally you will get this value. So minus 2 into 2b, minus 2b, so here it is 2b instead of b, and b square minus sorry, no minus is there, 2b square, 2b the whole square, so 4b square minus 4 into a into c, c is omega square, so omega square. So this 4 is common here, you can take that outside, so root of 4 is equal to 2, take it outside, then cancelling everything, so you will get this value, minus b plus or minus square root of b square minus omega square. Now this equation becomes, so a into e power of 40, that becomes a1 into exponential of minus b plus or minus square root of b square minus omega square into t, plus a2 into exponential of minus b plus or minus square root of b square minus omega square into t. Okay, so this is the solution after finding the roots. Okay, well, then we can find the values for different cases based on this b square and omega square. That is the frictional force constant values and restoring force constant values. So 3 cases, one is b square is greater than omega square, second one is b square is equal to omega square, third one is b square is less than omega square. Okay friends, meet you in another lecture. Goodbye.